Good evening and welcome to this session on deploying foundational models on Amazon SageMaker so you get the best price performance for your generative AI applications. My name is Venkatesh Krishnan and I lead product management for Amazon SageMaker. I'm joined today by my colleague Rama Thaman, who leads a team of specialist solutions architects who help our customers deploy foundational models on SageMaker and run performance tuning so that they get the best performance at the lowest cost. We are also super excited to have Travis Mellinger from Cisco Systems, who will talk to us about how they successfully leverage SageMaker to accelerate time to value for their foundational models. So let's get started. I'm sure you will all agree with me if I said that 2023 has been the year when generative AI took the world by storm. So if you follow Gartner's hype cycle, generative AI at this time is at the peak of inflated expectations. And this means that our customers are imagining every possible way that they can leverage generative AI to grow their businesses. But how can we translate this expectation into reality? It's been a great start to this journey, but how do we get to the destination quickly? How can businesses accelerate the time to value for their generative AI products? To answer these questions, let's start by double-clicking on the journey from experimentation to production scale deployment and see how we can switch to the fast lane. To start with, you experiment with different foundational models to see which one fits your use case well. Now, there are language models that can help you respond to user queries, summarize text, or even write a poem. Then there are models that can help you convert text into images or speech so that you can build visual or audio-based GenAI systems. Once you've played around and chosen your model, you may want to customize or fine-tune that model with your data. After that, the next series of steps are to deploy the model into production and integrate it into applications and products at scale. You start by choosing the appropriate model deployment platform, like SageMaker. Next, you have to tune your deployments to achieve your performance goals. And these goals could be latency, throughput, and scale. Of course, you also want to minimize your costs. So now, once you're done with performance tuning to achieve your latency, throughput, and cost goals in your dev environment, you want to set up your CI/CD pipelines for deploying the models into production in your test and prod environments. Finally, once you have deployed your models, you want to maintain it in production. So you want to monitor your model for quality and make sure that it's continuing to perform well. And then periodically, you want to update your model with a new version. And when this update happens, you want to do that without impacting your production deployments. As you navigate this journey, you have to strike the right balance between three factors so that you can achieve the best performance at the lowest cost for deploying your GenAI applications. These three factors are complexity, performance, and cost. Complexity manifests itself in terms of the size of the model. Or perhaps you're deploying, let's say, an ensemble of models, or you have a chain of models that you want to deploy together. Cost is an important consideration, and you want to minimize not only the cost of hosting the model, but also the operational overhead, the cost of the operational overhead. And then there is performance. Right? So if you're building an interactive application, you want to minimize the latency, the inference latency, to just a few milliseconds. If your application is serving millions of end users, then you want to achieve high throughput for your inference. These three factors, the cost, performance, and complexity, often pose a trilemma, which means that you can choose any two of these factors at your will, and the third one becomes a hard one to optimize. For example, let's say you want to deploy a very large model, right? And you have very stringent latency and throughput requirements. You will have to deploy these models on very powerful accelerated compute instances, GPU-based instances, and your cost will become very high. Let's dive into these challenges, starting with the cost of inference from foundational models. The most challenging computational step in obtaining inference from a foundational model is the large vector matrix and matrix-matrix multiplications that you have to perform. To implement these computations effectively, you need accelerators or GPUs that are efficient in calculating these matrix multiplication using parallel processing and high bandwidth memory. But these GPUs are expensive. For example, a P4D 24x large instance costs around $38 an hour. So if you run some back of envelope math, you will see that deploying a Llama 2 model on a P4D instance can cost you over $50,000 a month. Next, let's look at performance requirements when you are integrating foundational models into your applications in production. For interactive applications such as chatbots, the model needs to start responding in a few seconds, right? Even milliseconds if that's something you can achieve. So even if the response from the model takes several seconds, you want to start streaming tokens from the model and displaying them to the user to keep them engaged. Also, the time taken to generate inference varies quite a bit from one invocation, from one prompt to another. So the traffic you are sending to the model has to be distributed across multiple copies of the model. Now, once you've deployed the model into production, you want to periodically update your model. And when you do that, you don't want your application to shut down. You want them to be available 24/7. If you were to achieve that, then you have to stand up an entirely new deployment stack with a new model, and then cut the traffic over from the old model to the new one. So for that, you need 2x the number of instances at the time of these updates. With scarcity in GPU availability, this can become quite challenging. Also, when you've deployed your models in production, you will have to constantly monitor the instances and make sure that if any GPUs, if there's any hardware failure, you replace them quickly. This is important in order to minimize any downtime for your application. To address these challenges effectively, you need a very robust platform to host your models for inference. If you were to build and manage this platform on your own, especially for hosting these large language models, it will entail quite a bit of heavy lifting that can impede the pace of your innovation. And that's why you should go with a managed deployment service like Amazon SageMaker. SageMaker offers you the broadest range of inference options to serve any use case. So with SageMaker, you can deploy your model behind an endpoint and then invoke that endpoint with a payload via a RESTful API call and get the inference back in response to that invocation. You can use SageMaker's real-time inference for ultra-low latency predictions, or you can use batch transforms for offline inferencing on large data sets. If your inference requires you to use a large image file or a video to run predictions, or if the inference is likely to take a long time to run, then you can use SageMaker's asynchronous inference option. With SageMaker, you can either deploy a single model or multiple models, even up to thousands of models behind a single endpoint. You can also jointly deploy the pre-processing and the post-processing steps together with the inference step as a serial inference pipeline on SageMaker. At the infrastructure layer, you have the choice of deploying your models on either CPUs, GPUs, Inferentia, Graviton-based instances, or you can choose to go entirely serverless. So with SageMaker, you not only get the right model hosting option for your use case, but you also get the best performance at the lowest cost. Next, let us see how SageMaker can help you save costs of deploying foundational models. We're going to dive deep into 3 key features of SageMaker that will help you save costs. First, you can deploy multiple models on the same instance, and all these models can share the hardware resources that are available on the instance, and that way you save costs. Second, you can deploy models on SageMaker on an Inferentia or a Trainium-based instance. These instances offer up to 40% better price performance than a comparable generation of GPU-based instances. Yet another cost-saving feature in SageMaker is dynamic auto-scaling. So you can set auto-scaling policies to dynamically scale the instances behind the endpoint based on traffic. That way, you add instances only when you need it, and you scale down when there is not much traffic to save costs. Let's dive deeper into these features. With SageMaker, Okay. With SageMaker, you can deploy multiple models on a single instance so that the models share the resources on the instance, and you can allocate compute and memory resources on a per model basis. For example, if you deploy 8 different models on a single instance, you just pay 1/8 of the cost per model. For each model, you can assign a fixed number of accelerators or memory. You can also add models to existing endpoints and scale up and down each model independently depending on the traffic to that model. SageMaker will automatically add more copies of the model or remove copies based on the desired auto-scaling policy. And when SageMaker does all of this, it will efficiently bin pack the models using all available accelerators on the instance before adding new instances. Likewise, it will efficiently defragment the instances during scale down, packing as many models on the instances that are available. SageMaker also includes a smart routing algorithm that routes traffic to an endpoint very efficiently. At scale, the smart routing algorithm keeps track of which copies of your model are serving traffic and which ones are not, and accordingly routes new requests. And this saves an end-to-end latency of over 20%. You can save even more costs by deploying models on Inferentia-based instances. As I said earlier, these instances offer up to 40% better price performance over a comparable generation of GPU-based instances. And on SageMaker, this benefits stacks up over the ability to deploy multiple models on the same instance. So now on SageMaker, you can deploy multiple models on an Inferentia-based instance and get both benefits. Deploying models on Inferentia-based instances requires you to compile the model using the Neuron SDK. To make it super easy for deploying models on SageMaker on Inferentia-based instances, SageMaker automatically compiles the model at the time when the endpoint is set up. Let's talk about how SageMaker enables you to create interactive user experiences in your GenAI applications. Let's say you're building a chatbot that helps your customers plan a 3-day trip to their favorite destination. You don't want your web page to stay blank until the chatbot generates the entire plan. And this could take minutes, and your customers will lose interest. So SageMaker offers you the ability to stream responses back from your model as and when the responses are generated, as and when the tokens are generated by the model. Often, foundational models are too large to fit onto a single accelerator or a single GPU on an instance. As a result, you may not be able to deploy a very large model onto a single accelerator. Even for models that somehow barely fit into an accelerator, you will find it difficult to achieve low inference latency at scale. So you have to split the model into parallel shards and implement the inference across multiple accelerators on the instance. To improve latency, you may also want to quantize the model weights and the activation functions to int16 or int8 quantization instead of keeping them as floating point operations. Yet another technique to speed up inference is compiling models for the specific instance on which the model is deployed. However, implementing any of these optimization techniques will require a significant investment in time and specialized skill sets which are hard to find. So SageMaker packages all the goodness of the state-of-the-art optimization techniques into a single container, the large model inference container or the LMI container. This container is packed with libraries and tools that can help you automatically optimize and deploy your models to achieve best price performance. Here are some of the latest goodies that are packed into the LMI container. The LMI container includes libraries such as DeepSpeed that automatically parallelize your model for distributed inference. The latest LMI container also includes the TensorRT LLM library from NVIDIA with additional improvements that speed up inter-GPU communications to improve latency. So to make it easy to compile models using TensorRT LLM, the container includes a low-code interface that simplifies the compilation process for you. So all you need to do is specify the model ID and a few optional model parameters, and all of the heavy lifting which is required to build the TensorRT optimized model, the compiled model, is managed by the LMI container. The LMI container also supports continuous batching for inference requests so that you can improve your throughput. In addition, you can also leverage the latest quantization techniques such as GPTQ, AWQ, Smooth Quant. These are all available out of the box in the LMI container. So with the LMI container on SageMaker, customers can optimize large language models to achieve best-in-class price performance. For example, let's say you're deploying a Llama 2 70 billion parameter model using the LMI container on SageMaker, you get up to 33% lower inference latency and 60% better throughput than the previous version of the container. Let's switch gears and talk about post-deployment maintenance. Once you've deployed the model into production, you may want to periodically update the model with a new version or a version that has been further fine-tuned. SageMaker helps you update the model in production safely without impacting your production traffic or requiring 2 times the number of instances during the update. So with the rolling deployments feature in SageMaker, SageMaker can shift the traffic from the old model to the new one instance at a time, cleaning up the old fleet as the traffic shifts to the new model. So this minimizes the number of additional instances that you need in order to update your model. To show you how easy it is to achieve production-grade foundational model deployments on SageMaker and roll out your GenAI applications into production in a matter of hours, I now welcome my colleague Rama, who will show you SageMaker in action.
Benefits that Venki called out and also show you a demo of how easy it is to deploy a large language model on SageMaker. By show of hands, how many of you here have experience deploying a large language model? May it be SageMaker or an EC2 instance? That's a good number here. All right, so let's start with faster experimentation. Customers who leverage SageMaker tell us that they're able to shorten the time it takes to take a machine learning concept or an idea to production. They're able to do this because we have a comprehensive set of tools and models that allows customers to move quickly. Let's say if you have a summarization use case, you should be able to test your use case with a Llama model or a Flan T5 model or a Falcon model quickly, right? Should be able to experiment quickly. And many of you have experience deploying LLMs. It's very involved. You have to figure out what container to use. If you have to shard the model, what library to use. So today we launched a developer experience feature that simplifies all of those things. I'll show you a demo. In that, you don't have to worry about how to package the model for SageMaker, what container to use, what optimization strategy to use. And for faster experimentation, it's important to have these large language models at your fingertips. And we have SageMaker Jumpstart. It's a model hub where we have all popular open source as well as closed source models. With a few clicks, you could deploy those models onto SageMaker. Some allow you to fine-tuning as well. And having different inference options that Venki talked about, it's super important for lowering your cost. We had a customer where they had a personalization use case, and they had tens of thousands of models, one model per customers. In those cases, if you have to deploy 10,000 endpoints, it's cost prohibitive. It'll be huge. So in those cases, you need multi-model endpoints. Having fewer endpoints, multiple models behind the scenes, and SageMaker should do the magic for loading the model. So you need to have like multi-model endpoints, real-time endpoint, those kind of things depending upon your use case so that you could lower your cost. And also, many of these LLMs require accelerators. So having access to NVIDIA instances, Amazon own Inferentia, Trainium, all those are super critical for you to lower the overall cost. Many of the LLMs, like I mentioned, they use accelerators. So efficiently using these accelerators is very critical. Venki showed that NVIDIA P4D costs about $38 an hour. How do you efficiently use this? This is you have to pin the model to GPUs. For example, if a Llama model uses 4 GPUs, you should be able to pin the model to 4 GPUs, and the rest of the GPUs should be used for other models that you want to use. SageMaker does that heavy lifting. We'll take care of the model placement and so forth. All you have to do is specify how many accelerators you want to attach to that model, and we'll take care of it behind the scenes. Venki talked about the LMI container. It has all of these libraries and such that you can easily enable and optimize your inference. Model latency is the long pole in the tent where the time is spent in the container. Having that container super sharp and efficient is super critical. And that allows you to lower the throughput as well. Sorry, have higher throughput and lower latency. We also have smart traffic routing. When a model copy is not getting enough traffic, we know to send the request to that traffic. So that kind of intelligence is all built into SageMaker. You don't have to worry about, hey, should I do round robin or what have you behind the scenes. We'll take care of the best optimized routing for you. Lastly, compliance gets overlooked often. If you have to comply with FedRAMP or HIPAA or SOC, you need a lot of resources to manage this. And it's an undifferentiated heavy lifting that you have to do. SageMaker comes with those compliances out of the box that you can benefit from and lower your cost. These are some of the benefits. Let me now talk a little bit about cost. I want to compare the cost when you use SageMaker versus when you build your own platform, either on Kubernetes or EKS or what have you. So with SageMaker, you can see that there's a little bit of infrastructure cost, which includes compute instances, storage, network. And if you have your own platform that you're managing, you have infrastructure cost, you have operations cost. This is where you need people for upkeep of your infrastructure, patch management. If an instance goes bad, how do you replace it? You need people to build new features and the upkeep of the system. So there's a lot of heavy lifting that you have to do. On top of it, you need different features for security and compliance. You can see that the cost quickly adds up. But customers who leverage SageMaker tell us that they are able to lower the cost by 50% compared to their DIY systems that they had before. Now, let's transition and go into the demo. So for this demo, I'll show you 2 versions of it. One is through a notebook. Many people like to use notebook. If you're a data scientist or ML engineer, you'd like to use the code. I'll show you that version. I'll also show you a UI version where you could use the UI to deploy a large language model. So here, it's a 3-step process in the notebook deployment. First is you create a schema builder. Here, basically, you'll pass in a sample input prompt and a sample response. This is for us to figure out what serialization to use. As a user, you shouldn't worry about what serialization should you use. Plus, we'll also use that for testing the endpoint after the model is deployed. And the second step is to leverage the model builder class. You can see you can specify the model. Here, you can specify a location of your custom model. Let's say you built a model. This can be a tabular model or a classic model using XGBoost or scikit-learn or what have you. It can also be a LLM model. If you're using your custom model, put that on S3, reference the path here. We also provide you an option to just pass the Hugging Face model ID. Let's say if you're browsing Hugging Face Hub, you know a model that you want to test, you could just copy that model ID and pass it here. Or you could use also SageMaker Jumpstart model ID here. And then you pass the schema builder the role. And when you call build, behind the scenes, that's where magic happens, where we'll figure out the right container for you, the right packaging structure, the serialization, all of those things, so that there's very minimal learning curve for you to figure out, hey, how does SageMaker need the packaging to be? So that complexity is abstracted away now for you. And lastly, you can deploy the model, then run prediction. Let me show that in action for you. So for this demo, I'm leveraging one of the samples from Amazon SageMaker examples. It's a GitHub repo you all can access. There are multiple examples for different features. Just for inference alone, we have a section, and you can go find many of the examples for different features. What I'm going to do is I'm going to take the model builder example from here and run it on SageMaker Studio. So I'm navigating to AWS console, then to SageMaker Studio. In Studio, there is a profile set up for me, and I'm going to leverage that. If there is no profile for you, it's very quick to set up a Studio profile, and that will land me into SageMaker Studio console. This is a new console that we recently launched. It gives you multiple IDEs you can select. For this example, all I need is a Jupyter Lab notebook. So I'm going to click on Jupyter Lab to launch a notebook. I already have a notebook here. In the interest of time, I want to use that notebook. I'm going to click Open. And this will pull up a notebook with Jupyter Lab on it. And I have the notebook uploaded already here, the sample that I want to run. And you can also clone the entire Git repo that I showed you so that you could try out different examples there. But for this demo, I'll talk about the three main constructs you need to be aware of. The first one is schema builder, how you leverage that. Then the second one is the model builder class, like how would you use that. And the third step is you may have advanced use cases where you may want to override your load function or even the invoke function. I'll show you how to do that with Model Builder. So to begin with, I start with a few basic imports. I'm importing the SageMaker library, then also getting the execution rule that I need. Those are the basic things that you will need when you start. And here's my first step. It's creating a sample prompt. So you can see I have a prompt. It's a text generation use case. I want the LLM to provide more text about Diamondback Terrapin. And it's a sample prompt. I'm wrapping up in that schema builder. Then I could just leverage this to pass through the model builder. So it's just a sample that you have to pass. And we will figure out, based on the sample, we'll figure out what serialization you need to use. In the past, users had to provide that. That was not a good user experience, so we want to abstract away that complexity. Second step is to leverage the model builder. Here you can see I'm creating a sample working directory for the model builder to assemble all the artifacts and package and so forth. Then I leverage the model builder class, where I pass the model ID. Here I'm deploying a Llama 2 7 billion model. This is on Hugging Face Hub. I would just mention the model ID. Then I will pass the schema builder here. I also pass the sample working directory. Then I can specify a mode. This is a super important aspect here. You can specify whether you want to deploy the model on a remote endpoint on another instance, or if you're experimenting, you want to do this quickly, you could also deploy this model locally on the notebook itself if the notebook has the resources that model needs and if it supports Docker. So you can see you can quickly experiment. Also, you could deploy it on another endpoint. And finally, I call model.build. Here's where the magic happens, where we'll pick the right container for you based on the model, the packaging structure that SageMaker needs, the serialization that I talked about. All of those heavy lifting is done in that one line of code. In the past, you need to know all of these things upfront, but that's abstracted away. And with this, what happens is there's a package created, and you're ready to go now. Now you can deploy the model. So you could say model.deploy, pass the instance type that you need. You can also specify the number of instances you need behind that endpoint. And within a few minutes, you have the endpoint up and ready for you to run. And I'm running prediction in this cell. I'm using the same prompt that I used in the schema builder. Now you can see that the model provides me a lot more information about diamondback terrapin. It says that it's from eastern United States, the species, and a little bit more information about that. And that's exactly what I wanted to get. And you can see how quickly I can run inference against a large language model, and you could try different prompts that you want to try out. And now, in the same experiment, let's say if this isn't cutting it, you may want to change to Falcon model. All you have to do is change the model ID there. You can use a 13 billion parameter model or what have you and quickly run through. You can see how easy it is for you to experiment with large language models. In advanced configuration use cases, you can override your load and invoke function, pass your own code, and you use inference spec object, and you can pass that into the model builder, and it'll honor the code that you want to use. And finally, I will clean up the endpoint and so forth here. This is the notebook experience. You can see how simple it was, like 3 steps. You're able to deploy an LLM. If you don't want to work with the code and you want a UI experience, then I'll show you how to do that. So let me transition into showing you how that's done in the UI. Now I'm going to go to Studio Console. This is where we were when we began. So click on Models. There you can create a deployable model. Here, when you create, you'll be asked to pass the similar kind of information that I passed in the code. And at the end of it, you can create a deployable model. And behind the scenes, we'll do the packaging and such. And once that's created, you could deploy the model. So I have a bunch of those created already. And when I click on deploy, now behind the scenes, if you have benchmark for the model, we'll tell you what instance type to use. For some of the popular models, you don't even have to worry about, hey, what instance should I use? We will tell you because we have the benchmark. We'll also tell you the CPU requirements and all of those details. And you can just deploy the model and test it in the UI itself. So you can see you have 2 options, the notebook option and also the UI option to deploy the model. Let me invite Travis to talk about what their experience was in leveraging SageMaker for their use case.
All right, thank you for the introduction. My name is Travis. I work in a team called Collab AI in the WebEx business unit at Cisco. And our team's responsibility is to develop services to bring AI capabilities to features in the WebEx ecosystem. And to give you some sense of the scale that we're working with, I have some metrics that I've chosen from Cisco's WebEx marketing material. You can see in any given month we have 40 million monthly meetings. Across those meetings there are 160 million hours of meetings, and then 4 billion messages. And those meetings can be, they're one-on-one meetings, they are big team meetings, they're seminars, they're webinars. In those messages, they're large spaces the teams use to collaborate with one another. They are one-on-one spaces. They may just be announcement spaces. So we certainly don't need to make sense of all of that information, but you get some idea how much information we may want to pass through AI, ML inference in order to help our customers get better insights about how you're using the WebEx platform. And this is just one example of the kind of information, the data sources that we're using to build AI and ML capabilities. We also have our contact center platform. There's our security business. So you can see how it's important for us to be able to scale effectively and to do it cost effectively when we're talking about volumes of information like these. So I'll talk a little bit about how we use the SageMaker platform to do research and experimentation, how we enable our developers to quickly iterate on new features, to try new models, to be able to evaluate them, to compare them. I'll talk a little bit about one specific use case we have worked on. This is a summarization of calls. This will be from our contact center platform. And then I'll talk about future improvements that we can make to our services using a lot of what Rama and Vinky talked about in their segments of our presentation. So first, I want to talk about experimentation and integration. The key element of the picture there on the left is not necessarily Studio itself, but you can see that we've depicted the Jumpstart catalog there. And the Jumpstart catalog has been invaluable for our team to be able to choose models and then give us a very quick way to deploy them in an environment where they can not just test them themselves, we can give them access to make inference requests so they can see how they perform and how they behave, but they also have those models in the same place where they can deploy applications in our dev environment that integrate with those models. So we save a little bit of costs there, we can use them a little bit more efficiently, and they can be sure that when we're using the models in an application, they're behaving the same way that they're behaving when they're actually accessing them themselves. But the bigger win for us is just the sheer size of the catalog, and not just the size of the catalog and the number of models that are available in there, but the fact that the Jumpstart catalog gives you all of these models that you can try, in addition to the information you need to choose an inference container to put both of them together to then deploy it and be able to start serving AI and ML models without having to make all of those decisions yourselves. And then obviously, as my colleagues have talked about earlier on, SageMaker notebooks are invaluable. We have ML practitioners, ML engineers in our team, and this is a very familiar tool to them that they like to use in order to do their research, testing, development, experimentation. So I'll talk a little bit about the requirements that we had for this call summarization use case. One of them is obviously that we need to be able to evaluate large language models to determine their suitability for this particular problem. It is not enough, though, to choose a model that is appropriate for the problem, that it is accurate enough, that it is performant enough for a given use case. We also need to choose compute that is appropriate for those models, and we need to get a combination of a model and the compute resources that are cost effective for actually serving the use case. We also need to be able to do this globally. So Amazon makes it very easy for us to deploy around the globe in a cost-effective way, but we also need to satisfy localization and regulatory requirements in all the places around the globe where we are actually deploying, and not just satisfy those localization and regulatory requirements, but we also have different scaling requirements for any of those regions around the world. So we may have a hotspot where we have a lot of customers in one geographic region. We have many customers in the United States, and there are other geographic regions around the world where we don't have as much activity, and we need a good way to be able to scale those independently as efficiently as we possibly can, and SageMaker makes it very easy for us to do that. Again, as I just said, we need to scale effectively. The workload changes throughout the day and the week. There's a lot of activity during the day. Activity falls off at night. That kind of wave of activity moves around the globe, 5 days during the week and then off on the weekends. And we want to use features in the platform that SageMaker does for us in order to make those decisions about how and when we scale, instead of trying to do the heavy lifting ourselves and assuming that operational overhead. And then finally, container serving. And serving container selection is a challenging problem that we've also talked about earlier. It is difficult to get the combination of libraries, the combination of tools, the container image operating system, all of these factors come to versions of CUDA libraries in particular have caused us a lot of grief in our team. The SageMaker team makes it very easy for us to just choose a container appropriate for a given model, deploy it to an endpoint, and then we're on our way, saving us a ton of time and energy. So here you can see a high-level architecture for this ecosystem of services that I alluded to early on. And obviously this encapsulates more use cases than just call summarization. But I wanted to illustrate how our entire architecture fits together. So you can see there that there's a WebEx application on the left. We have summarization features. We have topic extraction features. We have chapterization features that integrate a number of different resources, products in the Amazon ecosystem. But the real key here is being able to perform inference against SageMaker endpoints, and any one of these applications can use one of those endpoints. And not depicted here, with these lines, is that where we do an ensemble of models to solve a particular problem, any one of those applications could reuse one of those endpoints. We could have a line from one of the pods in the EKS box to two of the SageMaker models and have a bunch of intersecting lines. Illustrating how we're able to use SageMaker inference not just to remove a lot of the operational overhead that we assume by doing those kind of things ourselves, but we can also reuse really effectively, and it's really easy with the integration between all of these Amazon services, particularly getting our pods running in EKS able to communicate with SageMaker endpoints. So I'll talk a little bit more about the implementation. So obviously we've chosen a large language model in order to perform summarization for call summarization. We ended up choosing the T5 XL foundation model. Our team has fine-tuned it. One way that SageMaker made it much easier for us to test and validate this model was to be able to deploy this model in multiple ways with different quantizations, which that was an effort we had to assume ourselves earlier on. That's a future improvement I'll talk about in a few minutes, how SageMaker will make it easier for us to do this in the future. But we chose T5 XL Foundation model. It gave us great performance, it gave us great accuracy, good throughput at an acceptable cost to us. The SageMaker ecosystem made it very easy for us to be able to test the combinations that I described, how we build that model and then integrate it in the application and then validate it for what we ultimately settled on in our model configuration. We also leverage SageMaker for predictable performance. We can scale effectively using SageMaker endpoints. We can, as I described earlier, we can scale out when we need more capacity. We can scale back in. There's another improvement we can make here that I'll talk about a little bit later on. But SageMaker autoscaling makes it very easy for us to look at metrics about how the model is performing and how applications are using it and get us the capacity we need in order to serve inferences and then scale back when we no longer need the capacity. Again, we use SageMaker's LMI containers. Building LMI containers is very difficult. Having that work done for us by the SageMaker team, having that maintained for us by the SageMaker team, where they handle the updates and not just the operating system, but the libraries. We're able to take a new version of the serving library. We're even able to take multiple versions of the serving containers, put them side by side at different endpoints, perform our own performance testing to see how they compare to one another. And we've done the effort of comparing those models on those inference servers to understand how they behave against one another without having to do all the work to prepare the testing by building those container images. And then finally, we get faster developer iteration at an optimal cost. I talked at the beginning about how we have some reuse. In our development environments, we can have applications that use endpoints, and then our developers can use those same endpoints. It saves our developers a lot of time to be able to use SageMaker endpoints that we can deploy and operate for them, instead of having them run those models on their own machines. There's some uptime, there's some startup time to running an application that loads a model into memory, that then performs inferences, and then they have to shut it down, and if they want to make some changes to how an application is using a particular model, without actually making any changes to the model itself, they're beholden to the cycle time of loading a model in memory to be ready for inference when they may only be making small changes to how an application works. So we can save them a lot of effort and a lot of energy by using SageMaker endpoints to point them to in order to do that work. And finally, we can make a lot of improvements in our architecture and in our services. One is we can deploy multiple models on same instances in order to maximize utilization. So we use single model endpoints right now. We have used multi-model endpoints in the past. It wasn't really a good fit for some of the models that we wanted to operate. We also tried using asynchronous inference, and we were advised that at the scale that we were working on for this particular issue, asynchronous inference wasn't really a good fit for what we wanted to do. Asynchronous inference was meant for really huge scale, and we weren't quite at the scale that was appropriate for asynchronous inference. Now that we have multiple models, with the bin packing and the automatic scaling features and the sharding, we can scale models out to the number of instances of a model we need to serve a particular workload. We can let them scale in when we no longer need instances of that model, and we can scale them all the way down to 0 when there is nothing happening at all, and have kind of a baseline number of smaller models hanging around that may get regular utilization while there's some capacity warm in order to then ramp those models back up again, while the SageMaker ecosystem, if we need it, will add additional underlying compute capacity with GPUs to serve additional instances of the models if we need them. We can, as I just said, scale models to 0 to optimize cost. We're using single model endpoints right now. We always have at least one copy of a model around. It would be really nice if we can get to 0. That we will be able to do very soon, much more easily than we had been able to do in the past, without having to rely on asynchronous inference for this particular use case that wasn't quite appropriate for what we wanted to do. And then finally, we can adopt all of these improvements to the SageMaker developer experience. We have specialists in our team today who have gotten really good at understanding how to build the models for a particular serving library, for a particular serving container, and packaging them and putting them in buckets and so on and so forth. Having the heavy lifting done for us by the SageMaker toolkit, where we can simply point it to an artifact, give us a model, put it in an S3 bucket, and then we can let our CI and CD take over to deploy and operate endpoints for us. So it will save us a lot of time and a lot of energy. Thank you very much for listening. I think now I'll hand it back to you for Q&A.